All right, so let's take a look at something called the 5D process. So right now in class, you are already working on this problem. As we go through the video, you definitely don't need to write down this top part because this is just the problem rewritten, and it was a pain to write it. But I do want you to take notes from this line down. So I want you to write this with me, even if you know the answer to this question, because we're practicing the 5D process. I want you to practice what we're doing here so you can kind of see the purpose in it. Now, here's the problem. The parent club at Post Falls Middle School needs 183 feet of fencing to go around the rectangular outdoor basketball court behind the gym. Let's put this down. The club volunteers only need to place a fence on the three sides of the court. That's because the building is on the other side. The length of the court is 32 more feet than the width. One of the shorter sides will be 5 feet shorter than the other to leave room for the gate. How much fencing will be used on each side? So the 5D process is a process for solving a word problem like this, where we have information about the relationship between the different missing parts, but we don't know exactly how to find them. In the future, you're going to write equations. If you're somebody who knows how to write an equation already, that's great. I still want you to see this process and understand it. First of all, what are the 5Ds? This is very confusing, but they call it the 5D process, but the first one actually has two words. So the first step is both of these things. We're going to describe and draw everything that's in the problem. Next, we're going to define, then we'll do, then we'll decide, and then we'll declare. And if those don't make sense yet, I will explain them in a moment, but for right now, just make sure you've written them all down. Okay, first step, describe and draw. In this step, we're going to describe the situation, and we're going to draw a picture if appropriate to help us understand. So, looking back at the problem here, we know that we're dealing with a rectangular fence, and we know that we only need to deal with three sides of the rectangle. So I wrote rectangle, three sides. And I know that this problem is about perimeter because it's talking about the length around the outside. Over here, I've drawn a picture. This is the wall for the building. I don't need to worry about this side. I drew one short side. I called this side 1. On the other side, I called this side 2, and I put 5 feet for the gate. So this is 5 feet shorter than this side for the gate. And finally, side 3 is 32 feet longer than this short side. So I tried to mark this off because I had graph paper. I made it actually the same length. It's easier to see. That's side 1 and up to here are the same length, and then I add 32. You might need to write more details to really be able to communicate all the information when you're working on these on your own. But for now, let's go with this because this gives us a decent idea of what we're doing here. So that's the first D. We've got all our information out there. The second D in the 5D process is to define. What that means is basically you're going to guess and check. You're going to try to define what these different sides are by trying a side for side 1, figuring out if that's side 1, what would side 2 be and what would side 3 be based on the word problem. So my first trial here is going to be, I'm going to try the number 10 for side 1. And we're talking about feet here, so that means 10 feet. For side 2, I use the information that I have from the problem. And I know that the other short side will be 5 feet shorter than this short side. So this over here is going to be 5 feet shorter. If this is 10, I show my work here. I show 10 minus 5 means side 2 would have to be 5. Side 3 is 32 feet longer than that first side. So I would do 10 plus 32, and that equals 42. I left myself just barely enough room here. Now, this is just, all we're doing is we're saying if side 1 was 10, what would side 2 be? It'd be 5. What would side 3 be? It'd be 42. We don't know yet if that's right. The do section is where we go and we take these numbers, we're going to add them all up to see if it's equal to 183. That's going to be our decide section. So, because it's a problem about perimeter, I'm going to take those 3 numbers that I got for the sides, I'm going to add those up. And when I add these up, that's going to give me 57. Next, you come over to your decide column, and we're going to decide, is this equal to 183? Well, obviously, 57 is not 183. So we could just write no here. Sometimes we are just going to write no or an X. But in this case, since as I increase the side length here, it's going to increase the perimeter, I know that I'm too low, so I'm just going to write the word low. And that's just a way for me to remind myself, okay, I'm lower, my next guess should be higher. So I'm actually significantly lower here. So my next guess I'm going to try 20. And if side 1 is 20, then I'm going to figure out that side 2 is 5 feet shorter, so that's 15. And side 3 is 32 feet longer, so that's 52. In the do section, we check to see what the perimeter would be then. So 20 plus 15 plus 52. And this comes out to, that's 35, that'd be 87. So we're getting closer, but we're still, we can see in our decide section, we're still too low. What I want you to do now is I would like you to, well, pause the video. The video is going to pause in a second and ask you. I want you to keep trying numbers for side 1 and see if you can get to the exact answer for side 1, 2, and 3 to make it so the perimeter is 183. Go ahead and try that now. Okay, so hopefully you were able to figure that out. If you weren't, or if you're still thinking about it, go ahead and watch these examples here. I'm going to try 2 more. I know the answer, so I'm going to try 1 more, and then I'm going to jump to the answer. So in this case, I had 87. I'm significantly lower still. So I'm going to try for trial 3. I'm going to go ahead and jump up even higher. I'm going to try 50. And if side 1 is 50, side 2 would be 50 minus 5, or 45. And side 3 would be 50 plus 32. That's a 3. Sorry, not a very good 3 there. And that would give me 82. So let's go ahead and add those up. 50 plus 45 gives us 95, plus another 82, 140, why am I not? I'm having a hard time with this math here. Let's see, that's 7, that's 177. And we're still just a little bit too low here. Now, some of you might have figured out a strategy here, and I just want to point this out to you because you might have been thinking about it. You may notice that every time I increase this side by 1, that will also increase this number by 1, and it will also increase this one by 1. So every time I increase this by 1, my total perimeter will go up by 3. So I can actually tell when I get close enough that 52 is going to work. Because I was 6 below the number that I needed. So let's watch why that works. So there's 52. 52 minus 5 is 47. Oops, I kind of went over the edge there. And 52 plus 32, I always get a little messy, is 84. When I go to add these all up, 52 plus 47 is 99, plus 84 is going to be 183. And I usually put a check mark there to show that I got it. So that's actually, we've only done 5 of the D's. The final D here is the declare section. So once you've gotten to your answer, in the declare section, you're just going to write the answer that you got. So the problem is asking about all 3 sides. So I would write side 1 is 52 feet. Side 2 is 47 feet. And side 3 is 84 feet. And that's the 5D process. Now, when you go to do this in other problems, they're not always going to be about perimeter. Some are going to be about something totally different. But the framework is still going to be the same. We're still going to describe and draw. We're still going to guess a number and then figure out what the other numbers would be based on that. We'll check against something else like the perimeter or some other bit of information, and then we'll adjust our guesses as we go. All right. Thanks for watching.